How did you represent this problem? Say it out loud. I heard some scholars say that they first broke the shape into two smaller rectangles by drawing a line from the inside corner to the 9 feet side. I heard them mention that this allowed them to see the length and the width of the top rectangle, which are 4 feet and 3 feet. And for the bottom rectangle, we can see that the length is 6 feet. Great job. What can we do to find out the width of the bottom rectangle? Say it out loud. Yes, we know the length of the longer side is 9 feet, and we know the top part of the opposite side is 3 feet. This means that the top part of the longer side is 3 feet as well, because we know that the opposite sides of a rectangle are always equal. Since the whole long side is worth 9 feet, and the top part is worth 3 feet, then the bottom part of the line must be 6 feet, because 9 minus 3 equals 6. And since opposite sides of a rectangle are equal, we know if this part is 6 feet, then its opposite side must also be 6 feet. What did you do next to solve this problem? Say it out loud. Correct. We can write an equation to represent how we would find the area of the entire figure. I heard some scholars say that they would write 4 times 3 plus 6 times 6 equals A, and label these as 4 times 3 is the top rectangle, 6 times 6 is the bottom rectangle, 4 is the length, and 3 is the width of the top rectangle, and 6 is the length, and 6 is the width of the bottom rectangle, and A is for area. How would we solve this equation? Evaluate. Right. We can find the area of the top rectangle by multiplying 4 times 3, which equals, yes, 12 square feet. We can then find the area of the bottom rectangle by multiplying 6 times 6, which is, yes, 36 square feet. Finally, we can add the two areas together. 12 plus 36 equals, yes, 48. So the area of the shape is 48 square feet. Nice work. You broke apart the shape into two rectangles, found the area of each rectangle, and added the areas to find the total area. What is another way that we could have used? What is another strategy that we could have used to solve this problem? Say it out loud. I heard some scholars say that we could use a strategy that we learned yesterday, we could add on a line to the top of the shape so that we have a large rectangle and a cutout rectangle. What is the next step that you would take to solve this problem? Say it out loud. Yes, we can see that the length and width of the larger rectangle are 9 feet and 6 feet. For the smaller rectangle, we could see the width is 3 feet. But we don't know the length. Since we know that opposite sides of a rectangle are always equal, we see that the length on the bottom is 6 feet. And the part of the length on the top is 4 feet. Since the top line needs to be equal to 6 feet as well, then we know that our missing part is correct, 2 feet, because 6 minus 4 equals 2. Great work. What did you do next? Say it out loud. I heard many scholars say that they wrote an equation to solve the problem. What was the equation that you wrote to solve the problem using this strategy? Say it out loud. Right. We can write 9 times 6 minus 3 times 2 equals A, where 9 times 6 represents the large rectangle and 3 times 2 represents the cutout rectangle. And 9 and 3 represent the width, and 6 and 2 represent the lengths of those rectangles, and A is the area. How can you solve this? Evaluate. Correct. We can first multiply 9 times 6, which is, yes, 54. And then multiply 3 times 2, which is, yes, 6. Since we are removing this part from the larger rectangle, we want to subtract the area of the smaller rectangle from the area of the larger rectangle. What is 54 take away 6? Yes, it is 48. The area of this figure is 48 square feet. Did both strategies arrive at the same answer, even though the steps were different? Evaluate. Yes, both strategies worked to help us find the area of the figure. Our area won't change even if we use a different strategy. Today, you have 2 strategies in your tool belt that you can use to find the area of rectilinear shapes. You can break the shape into 2 smaller rectangles, find the area of each rectangle, and add the areas together to find the total area. Or you could find the area of a large rectangle and the area of a cutout and subtract the area of the cutout from the area of the larger rectangle. Each strategy might be easier at certain times than others. Today, I want you to think about which strategy is easier for you and which strategy makes the most sense for each shape. Think about this as you try one more.